Hey everyone, and welcome to this explainer. Today, we're going to break down a notoriously tricky WAEC chemistry past question from 2026. Now, if you've been grinding away, studying for your upcoming exams, you already know the deal. Sometimes it's not just about what you know, but how carefully you actually read what's right in front of you. Our goal today is to give you the exact tools and, honestly, the deep understanding you need to completely ace your exams with QandAHelp. We're going to map out the logic behind pure substances and mixtures so you literally never second-guess yourself on this topic again. Ready? Let's get into it.
Section 1. The Chemistry Challenge.
All right, we're diving straight in and putting the challenge right up front so we know exactly what we're up against. Take a really close look at this WAEC question. It asks, which of the following substances is not a mixture? And our options are A, iron rod, B, urine, C, seawater, and D, brine. Just read it over to yourself one more time. Can you spot the trap right away? Because I promise you, the examiners are testing way more than just your basic chemistry knowledge here. They're testing your attention to detail under serious exam pressure.
Did you catch it? The absolutely crucial point here is the word not. Missing this single tiny word will lead you straight down the wrong path. See, your brain is naturally wired to scan for familiar terms, right? And when you see the word mixture, you might just reflexively jump to pick the very first mixture you see in the options. But that word not completely flips the script. We are explicitly looking for the single option on that list that is a pure substance.
Section 2. Mixtures versus pure substances.
Okay, so before we interrogate our four suspects and lock in an answer, we really need to establish the ground rules of our investigation. To confidently separate the right answer from the wrong ones, we absolutely must be clear on the scientific difference between a mixture and a pure substance. First up, the mixture. A mixture contains at least two different substances joined physically. That means they actually retain their original chemical identities, and their composition can vary. Think about mixing salt and water to make a salt solution. Even though they're all mixed up together, the salt is still salt and the water is still water. No new chemical bonds were created. Plus, you can have a super salty glass of water or just a slightly salty one. The ratio isn't fixed at all, but both are still just mixtures.
But on the flip side, a pure substance has a fixed, definite composition. It absolutely does not vary. A pure substance is made up of only one type of material all the way through. This could be an element, which, as you probably remember from the periodic table, contains only one specific type of atom. Or it could be a compound, like pure H2O, where different elements are chemically bonded together in an exact, unchanging mathematical ratio. You can't just casually separate the hydrogen and oxygen in the glass of water without causing a major chemical reaction.
And this really hits the nail on the head. Iron is just a single chemical element, while salt water is a physical combination of entirely different materials. Just look at the comparison for a second. The pure element is completely uniform all the way down to the atomic level. The mixture, though, it's kind of a chaotic blend of different molecules just sharing the same space. Keeping this visual right in the front of your mind is going to make answering our exam question an absolute breeze.
Section 3. Testing the four options.
Let's put options A, B, C, and D under the microscope and build our case by eliminating the imposters. We want to see which ones are just messy physical blends and which one is our uniform pure substance. Let's actually start with option B, urine. Well, since it's physically composed of water, urea, and various mineral salts, it is firmly classified as a mixture. I mean, our bodies use it to flush out a highly variable blend of excess materials and toxins. Because it contains multiple different components just sloshing around together without chemical bonds uniting them, we can confidently place a giant red cross next to it. Option B is a mixture, so it's definitely not our answer.
Similarly, seawater contains water, dissolved salts, and gases in totally varying proportions. That means it's also a mixture and gets crossed right off our list. Think about it. The salt content of the Dead Sea is vastly different from the salt content of the Atlantic Ocean. Because the exact composition can change from place to place, and it's full of dozens of different dissolved minerals and gases for the fish to breathe, it completely fails the test for a pure substance.
Moving on to option D, brine. It sounds like a fancy, complex chemical name, right? But it's really just a highly concentrated solution of salt and water, which means it's just two substances physically mixed together. In industrial and culinary terms, brine is simply water that has had a massive amount of salt dumped into it. It's really just the exact same concept as the seawater we just looked at, only a bit simpler. Just salt and water. A physical blend. A mixture. Cross it out.
Now,
This brings us to option A, the iron rod. What's really interesting here is that in basic school chemistry, an iron rod is treated purely as the element iron, making it our elusive, pure substance. Yeah, in the real world of construction, steel or iron rods might contain trace alloys, but for the purpose of WAEC, JAMB, and NECO exams, an iron rod signifies the element Fe straight from the periodic table. It consists of entirely one type of atom. No variable composition, no physical mixing with other substances. It is definitively pure.
So, laying all the evidence out side by side, the path to the correct answer just reveals itself logically. By systematically checking the contents of every single option, we definitively conclude that the iron rod is the only option that is not a mixture. We found multiple substances in urine, seawater, and brine, leaving option A as the undeniable correct choice.
Section 4, the fast classification shortcut.
It's great that we solved question 3 together, for sure. But I want to give you a tool that you can apply to literally any substance an examiner throws your way in the future. By quickly running any substance through this two-step questioning process, you can effortlessly classify it as a mixture or a pure substance. Whenever you're stuck, just ask yourself, step 1, does it contain 2 or more different things mixed together? If yes, boom, you have a mixture. If no, you move to step 2. Is it a specific element from the periodic table or a single pure compound with a chemical formula, like H2O or NaCl? If yes, it's a pure substance. Memorize these 2 simple steps and you're going to save precious minutes during your exam.
Section 5. Quick chemistry quizzes.
Knowledge is only powerful if you can apply it dynamically. So let's run through a quick workout for your brain. Look at these 4 everyday items. Can you use our new shortcut to isolate the pure substance? We've got air, distilled water, soil, and a soft drink. Apply step 1 and step 2 in your head right now. Which one has a definite composition, and which ones are physical blends? Take a second.
If you guessed B, excellent job. Distilled water is a pure chemical compound, whereas air, soil, and soda are all messy physical mixtures of multiple ingredients. Distilled water has had all its impurities and dissolved minerals totally removed, leaving only pure H2O molecules. Soil is a complex mix of rocks, organic matter, and water. A soft drink is a mix of carbonated water, sugar, and flavorings, so they're all mixtures except B.
All right, let's flip the script and try to find the mixture among this new lineup. We have A, oxygen, B, copper, C, sodium chloride, and D, air. Use the shortcut again, but remember, this time we are hunting for the substance that contains 2 or more things physically combined.
And the answer is D, air. Air is essentially a giant physical mixture of nitrogen, oxygen, and carbon dioxide, while the other 3 options are elements or pure compounds. Oxygen and copper are elements found right on the periodic table. Sodium chloride is a pure compound with a strict chemical bond, but the air we breathe, it's roughly 78% nitrogen, 21% oxygen, and a mix of other trace gases all sharing the same atmospheric space. Option D is our mixture.
Okay, for our final challenge, think back to our detective work earlier. What makes brine a mixture? Is it A, because it contains only salt, B, because it contains salt and water, C, because it's an element, or D, because it has one type of particle?
Yep, the correct answer is B. Brine is just salt physically dissolved in water, meaning they can still be physically separated without breaking any chemical bonds. Just think about the physical process of mixing. If you were to take a pot of that brine and boil it on the stove, the water would evaporate entirely, leaving the pure salt crystallized right at the bottom of the pot. Because they can be separated by a simple physical process like that, it's a mixture.
Based on everything we've decoded today, I want you to take a look around your kitchen right now. Your tap water, your cooking oil, your favorite juice. How many of those are actually pure substances, and how many are secretly complex chemical mixtures in disguise? Run them through the 2-step shortcut and find out. And hey, to master even more crucial exam questions across all your subjects, head over to QandAHelp.com. Keep practicing, stay curious, and I'll catch you in the next explainer.